So far, in all of our games, every time that we need to create a particular game entity, the way we've done it is create a sprite and then assign some properties to that sprite. That's how we've done it so far. Sometimes you want to create multiple elements of the same type and they all have the same properties. Moreover, sometimes they might even have their own behaviors. You might want to have a custom method for a particular type of object. So wouldn't it be nice if we could create our own types of objects that behave like a sprite in all possible ways? So we can assign their coordinates, we have access to all of these amazing methods that sprites have, but we can add things on top of that. Some of these things we might want to add are default values for some properties, and then even our own custom methods. In this lesson, I'll create the first type of these objects. They're called prefabs in Phaser. And it will be the player bullets. All player bullets are going to have the same similar type of properties, so I'll use that as an example. And then later on in the course, we'll create other types as well, and they'll have more specific methods. In this, in our first case, this type of object is not going to have any type of special methods, but just different default properties. So the first thing to do is to create another folder called prefabs inside of JS, and then a file called playerbullet.js. Since we're creating a new file, don't forget to include it in index.html. Every time you create a new file, you have to include it, otherwise it will not be loaded. So if you go now to that file, we are going to begin by using our same namespace pattern that we've been using so far in this module. And then we're going to define this object. You already know how to create custom objects in JavaScript, but in this case we're doing something a bit different. We're not only creating our custom object, but this object needs to behave in all possible ways like a sprite. The term for that is that this new type of object, which will be the player bullet, inherits from the phaser.sprite class or object. So it will behave like it in all possible ways. The way to implement inheritance in JavaScript might seem a bit unintuitive at first because it uses some keywords that don't make much sense unless you really read deeply into the language. But it's always done this way, so you'll do it the same way each time. So I'm going to use my namespace, of course, and then give this object a name. It will be called player bullet, and it will be a function because that's how we've seen it in the past. We'll give it some parameters. We're going to pass the game and coordinates. So every time you create a bullet, you'll pass it the game and you'll pass some coordinates. Then how do we actually define this inheritance thing? We need to set the prototype of the object, and the way to do that is like so: phaser.sprite.prototype. What this is doing is basically creating an object that is similar or that is the same type as this one. So we create an object just like the prototype of the sprite, and that's going to be the prototype of our bullet. Also, you have to add you have to specify what the constructor of this property is, so that when a new one is created, it knows what method it should call, and the constructor is this. So when a new object is created, this is what's going to be called. Okay, last thing that has to do with inheritance. We've said that we inherit from sprite. Now also when we're creating a new entity, a new instance, we need to pass all this stuff to the sprite. So the sprite obviously needs X, needs Y, needs a game, and needs also a key for the asset. The key for the asset is going to be bullet that we've already preloaded. So what I'm going to type now is phaser.sprite.call. We pass the context, the game, X, Y, and the key of bullet. By doing this, we are saying that when we create a player bullet, it basically needs to create a sprite, and we pass the corresponding parameters. and we give it already a key, so you don't have to enter a key. You could, if you wanted, to be able to specify what the bullet will look like, but in this case, they're all going to look the same. And now finally, we can set our custom properties. So again, up to this point, this is the same for all custom objects that inherit from sprite. This might change a bit, so this could be a parameter instead of a predefined value. Obviously, this could be also predefined values if all of your elements were to appear in the same place. But this is just how it's done in JavaScript and in Phaser. And now we can start adding our own things. So I want all the bullets to have an anchor point in the middle. So now I don't have to manually set this every time I create a bullet. They all will have the anchor point in the middle. Also, I want the bullet to die if it leaves the screen. When a bullet leaves the screen all the way up, when it's out of the game world, I want the bullet to be marked as dead. In that way, we can reuse it in our pool of objects. If we want to kill objects that leave the screen, we have to set two flags to true. The first flag is called check world bounds. It basically means keep an eye of when this sprite leaves the world bounds. And then out of bounds kill is set to true. So keep an eye on this sprite when it leaves the world, then kill it. That's basically what we're saying here. So that's our player bullet prefab. And now we can create these in our game state. So let's go back to create bullet, to the create player bullet method. And if there's no bullet, we need to create one. And now we know how to do it. So bullet will be equal to, instead of new, it will be equal to new space hipster dot player bullet, and then we pass it the game, we pass it the coordinates, which will be the position of the player, the position in Y of the player. But actually, we don't want the middle, we want the top, so that we can just type in top, and it'll appear on the top on Y. So it'll appear here in the middle on X and on top on Y. So we create this new bullet and we need to add it to our group. So the group is called player bullets dot add, and we add bullet. If bullet is not already created, we reset. If it is already created, we'll just reset the position. So see how we're treating it just like if it was a sprite. There's no difference on how we're treating it. Player.x, this.player.top. By the way, you can type in this.player.position.x, or you can just type in this.player.x. It's the same thing. Also, the velocity bullet.body. So see how also the bullets have body. They're sprites in all possible ways. I'll keep on repeating that because it's very important. Velocity.y equals this.bullet speed, which is what we defined at the beginning in our init method. Bullet speed. Okay, so let's see if we're actually having bullets. Yes, so as you can see, the spaceship is now throwing bullets. And if we want to know how many bullets are being created at all, we can just type in game state in the console, game state dot player bullets. So that gives us, it's space hipster, right? Because that's our namespace. Dot game state dot player bullets, and then that gives us the group object in the console, and we can expand on that and then go to children, and children actually has 3 elements. So there's only 3 elements at a time in the game, three bullets at a time. If we had a faster rate, maybe we would get 4 or 5, but as you can see, we're not creating more objects, we're just recycling 3 different bullets. So to summarize what we've done, instead of just creating sprites and then setting the properties for each one of the sprites, we're creating bullets. We create a new type of object called player bullet, and then we just treat it just like a sprite. That type of object is a prefab. It inherits from sprite in this, I know, complicated that thing that doesn't make much sense, but it's how you inherit in JavaScript. Inside of the bullet, it basically calls the sprite initiation method, and then it sets custom properties that the way we want it to behave. Later in the course, we'll look at other prefabs that also have their own methods, so that makes it even more of a powerful approach, and it helps you keep your code organized and separated so that it's easier for you and your team to maintain.